Hi everyone, let me show you my submission for OpenAI's Build Week. You know, I really like retro gaming, especially playing old Pokemon games, but they take so much time. So I checked what alternatives I would have sticking with original hardware, and nothing really fulfilled my needs. So together with Codex, I developed an overclock mod that's inside here. You see here like latest PCB version of it, and well, this is actually the one that's inside, unpopulated PCB. And yeah, what I wanted to have was the possibility to tweak the overclock to exactly the speed that the console supports. So typically, especially these IPS displays that you put in here nowadays to have a nice screen, they support very different speeds as maximum until they drop out. So this mod walks you through a calibration guideline, and yeah, Codex helped a lot here with developing the firmware for that. And with that, you can really find the maximum supported overclock speed for the console and the game and the IPS display inside here. So in addition to that, I also used Codex for hardware debugging, to development with KiCad. Like this board here is the programmer on the left-hand side and the tester on the right-hand side. And for Build Week, I focused more on the software side, especially more options to debug the firmware development, not always on device, so I don't have to flash this microcontroller unit inside here that does all of the overclocking handling, and can do more of that already in software, already on my PC. So let me change to the PC and walk you through what I developed.
So here you can see the software workbench. Now we can simulate the actual console behavior. Turning it on, see the initial frequency. Now pressing the buttons, can cycle through frequencies. We see that the MCU is awake. After some inactivity, it goes to sleep. Can even hold all of the buttons here. You go through the menus that the console supports into this calibration mode, for example. All of that can be nicely simulated. You always see in which state you are, where you are, what you're doing, what the console is doing. Power cycles. And then down here, we can run dedicated scenarios. So check that all of the communication between the MCU and the overclock IC and the LED, all of that does what it's supposed to do. And also here you have the option to do some fault injection to check if everything is detected correctly. So at the end, this one helps to do a lot of debugging in software, and I don't have to do this constant back and forth of MCU flashing and testing in real hardware. All of that was developed with one big goal session, working through 13 milestones. So Codex 5.6 really delivered and helped a lot here.